So when you hear it's passing by Mars, it's passing by Mars at a...
Something truly extraordinary and profoundly unsettling is unfolding in our solar system's backyard. The interstellar object 3I/ATLAS, a cosmic enigma hurtling from beyond our stellar neighborhood, is surrounded by bizarre metallic anomalies that defy all known principles of astrophysics. And here's the jaw-dropper. These structures are quadrupling in size and number at an unprecedented rate. This isn't merely a curious blip on a telescope. It's a rapidly escalating crisis that has NASA on high alert, bracing for a potential catastrophic impact on Mars. In just a matter of weeks, the interstellar comet 3I/ATLAS, discovered on July 1, 2025, by the ATLAS telescope in Chile, is set to make its closest approach to the Sun, passing between the orbits of Mars and Earth. This object, the third confirmed interstellar visitor after 1I/Oumuamua, 2017, and 2I/Borisov, 2019, follows a hyperbolic trajectory that screams its alien origins. The sheer scale of these multiplying metallic forms is staggering, and their origins remain shrouded in mystery, leaving scientists grappling with questions that challenge the very foundations of our understanding. To put it bluntly, the stakes of this cosmic drama couldn't be higher. NASA's Martian nightmare began with the first visual confirmations. High-resolution images from cutting-edge telescopes like the Hubble Space Telescope and the James Webb Space Telescope revealed faint, indistinct shapes clustering near the comet's nucleus. Initially, astronomers dismissed these as potential artifacts, perhaps dust grains or optical illusions caused by the comet's outgassing. But as observation time grew and data clarity sharpened, the reality became undeniable. These were no mere fragments. They were solid, reflective structures, distinctly metallic and unlike anything expected from a comet. Most shockingly, these objects displayed geometric shapes, angular, precise forms that sparked intense debate and speculation within the astronomical community. The situation escalated from puzzling to outright alarming when researchers realized these metallic anomalies weren't static. They were growing, explosively so. Early observations noted a dozen or so objects, each roughly 15 feet across, the size of a compact car. Within weeks, their numbers surged to several dozen, with individual sizes swelling to 40 feet, comparable to a small house. Now, months later, the data paints a chilling picture. Hundreds of these structures, some stretching over 200 feet, hover ominously around 3I/ATLAS. What's often overlooked is the eerie consistency of this growth, a pattern too precise to be dismissed as random cosmic chaos. According to recent studies, such rapid, organized expansion is unprecedented in cometary behavior, hinting at processes far beyond our current models. The implications are nothing short of staggering. Traditional comets are icy conglomerates of frozen water, carbon dioxide, methane, and dust with rocky inclusions. Yet, 3I/ATLAS's metallic anomalies tell a different story. Spectroscopic analysis reveals significant presence of metals like nickel, iron, and even traces of rarer elements like cobalt, with unusual emissions of nickel vapor unaccompanied by expected iron signatures, a phenomenon unseen in solar system comets. These findings, coupled with cyanide emissions, deepen the mystery of its composition. This interstellar interloper challenges everything we know about comet formation, particularly for an object born in the depths of another star system. Could 3I/ATLAS represent an entirely new class of celestial body? NASA's primary concern, driving sleepless nights for its scientists, is the growing threat of a Mars impact. 3I/ATLAS's trajectory brings it perilously close to the red planet, with its closest approach on October 3, 2025, at approximately 18 million miles, 29 million kilometers, near enough for Mars-orbiting spacecraft like NASA's MAVEN and ESA's Mars Express to capture detailed data. Initially projected as a near miss, the presence of these expanding metallic anomalies flips the script. These are no longer insignificant specks. They're massive objects, each carrying tremendous momentum. If even a fraction of these structures breaks free from the comet's gravitational grip, perhaps propelled by an unknown internal force, they could become independent impactors, transforming Mars into a cosmic shooting gallery. The thing nobody tells you is that a single metallic projectile, even one the size of a school bus, striking Mars at tens of thousands of miles per hour, could unleash chaos. Mars's atmosphere, a mere 1% as dense as Earth's and composed primarily of carbon dioxide, is fragile, with an escape velocity of just 5 kilometers per second. A single impact could carve a crater miles wide, ejecting enough dust to cloak the planet for decades, disrupting its delicate atmospheric balance. Historical impacts on Mars have produced global ejecta blankets up to hundreds of meters thick, altering climate patterns. Such an event could devastate ongoing missions like the Perseverance rover, which is collecting samples for Earth return, and jeopardize future human exploration by rendering the surface inhospitable. This isn't just about Mars, it's about unraveling the fabric of our universe. The origins of these metallic anomalies hold the key to this cosmic puzzle. While speculation about extraterrestrial involvement swirls among enthusiasts, scientists remain cautious, demanding hard evidence. Yet the sheer strangeness of these quadrupling structures makes it hard to dismiss the whispers entirely. If this growth continues unabated, what will these anomalies become? And how will they shape the future of Martian exploration? We stand on the precipice of a discovery that could redefine our place in the cosmos. Whispers of a new physics are growing louder. The quadrupling of these metallic anomalies, both in number and size, defies all known astrophysical processes. Unlike the gradual expansion seen in cosmic phenomena, like the universe's dark energy-driven acceleration, this localized exponential growth is a scientific anomaly. Normal cometary processes like outgassing or fragmentation can't account for such rapid, uniform multiplication of dense metallic structures. This behavior suggests forces at play that we don't yet understand, pushing researchers to question the very rules governing celestial mechanics. One bold hypothesis posits that 3I/ATLAS isn't a comet at all, but a novel type of interstellar object. Estimated at up to 20 kilometers wide, larger than Manhattan, its massive size and exotic composition hint at origins in a distant star system, perhaps Alpha Centauri, 4.37 light-years away. These metallic anomalies might not be separate entities, but extensions of a singular, complex structure, an interstellar seed activated by our sun's radiation, sprouting metallic appendages in a process akin to cosmic blossoming. Such a theory demands a radical rethinking of how interstellar objects form and function, suggesting a level of self-organization that borders on the incomprehensible. Another compelling idea explores the role of powerful electromagnetic fields. Could 3I/ATLAS act as a cosmic forge, generating intense magnetic fields that coalesce free-floating metallic dust and gas into structured forms? Space is rife with charged particles and microscopic debris, and studies have detected heavy metal vapors like nickel in comets at vast distances from the sun. If 3I/ATLAS harbors a mechanism to aggregate these materials, it could explain the quadrupling effect. But what powers such a stellar engine within a seemingly inert comet? This puzzle fuels relentless data analysis, with NASA's Deep Space Network working overtime to process incoming signals. The notion of new physics is being whispered among the scientific elite. When observations defy existing models, it signals gaps in our understanding. Some quantum field theories suggest that under extreme conditions, matter can form complex, stable structures where none should exist. While speculative, the consistent growth of these metallic anomalies pushes the boundaries of what we deem possible. Researchers are revisiting once dismissed theories, scouring for explanations that match the bizarre data flooding in from deep space. Mars now lies squarely in the crosshairs. The once assured near miss has morphed into a dire threat, with NASA mobilizing contingency plans for a potential impact. Mars, spanning roughly 4,200 miles in diameter, is a delicate target. A barrage of metallic objects could wreak havoc, with even a single impactor carving craters and ejecting dust that could shroud the planet for years, disrupting solar-powered missions and accelerating the loss of scarce water vapor. The Deep Space Network's 70-meter antennas are tracking these anomalies, but their sheer number, now in the hundreds, makes precise monitoring a nightmare. Planetary defense concepts, typically reserved for Earth, are now being adapted for Mars, with ideas like deploying small spacecraft to nudge larger fragments off course. Yet, if these anomalies are self-replicating, such interventions could backfire, creating more impactors. This crisis has sparked unprecedented global collaboration. Telescopes worldwide, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, are pooling data, while scientists share algorithms to track these anomalies. This unified effort highlights humanity's strength in facing cosmic unknowns, laying the groundwork for future planetary defense strategies. The wow factor lies not just in the metal itself, but in the vastness it represents. 3I/ATLAS, having traveled perhaps trillions of miles, carries clues to the resilience of cosmic phenomena across star systems. Looking ahead, this event will reshape space exploration. Future missions will prioritize early detection of interstellar objects, potentially launching probes to study them up close. The mysteries of 3I/ATLAS could drive the next leap in our cosmic journey, unraveling the galactic tapestry. Are we witnessing a natural phenomenon, or something more? The saga of 3I/ATLAS challenges everything we thought we knew, leaving us to wonder, what cosmic truths await discovery?